Hi, my name is Rafael Kevin Einagal. You can call me Sir Kev. These series of video-based modules will be based on the topics under Earth and Life Science for senior high school. Write your comments below for improvement. Don't forget to hit like, share, subscribe, and the notification button. Thank you. Earth and Life Science deals mostly with the study of the Earth, but we will learn later on that it isn't just the situation. Our first lesson for today is about the formation of the universe and the solar system. As we can see, the Earth is a vast area if we look at it in our own perspective. However, it's just part of the universe itself. So, what is Earth science? Earth science is a very broad topic. It encompasses all the sciences that seek to understand the Earth and the Earth's neighbors in space. And these neighbors include the other planets, the Sun, the stars, the moons, the asteroids, comets, and other celestial bodies. Earth science includes the study of geology. Basically, it's the study of the Earth. Also, oceanography, which deals with the study of oceans, meteorology, which deals with the study of the atmosphere as well as the weather. Finally, it also deals with the study of the entire universe, which is astronomy. The beginning of the universe can best be explained by several theories about its origins. Raya mga theories na ra ay mga popular nga theories regarding the universe and its origins. However, I have only chosen five major theories to be discussed here. The first one is the Big Bang Theory. Daya nga theory ay proposed ni George Lemaitre. It is actually the most popular and widely accepted theory. It was stated that 20 billion years ago, the universe started from compressed and condensed matter and energy, and that was in a hot, dense state. So, when all of these compressed matter and energy gathered together, it exploded like in a Big Bang. And, well, the particles started to spread out. This is the beginning of the universe, according to the theory. So, it was illustrated like this one. The second theory is the steady state or the infinite universe theory, proposed by Hoyle, Gold, and Bundy. According to this one, the universe has no beginning and no end. So it constantly expands continuously and constantly. So it's like it's also the theory about the multiple universe or the multiverse theory. Like there is one Earth from one universe and another Earth in another universe. So it's constantly expanding and expanding. The next, this is an illustration of the multiverse theory. So deep within those other universes, there are other universes where we can find the Earth in our solar system. The third theory is the Big Crunch theory. This is the complete opposite of the Big Bang theory and was based on Einstein's theory of general relativity. Hambang sa raya nga theory na ra, the Earth kuno naghalin sa the same thing, matter and energy. However, instead of continuously expanding, it's continuously condensing. Um, it combines with each other, all the matter and the energy, until such time that there was a big crack. And out of that big crack, everything also seeped out and it became the universe as we know it. Kung the Big Bang nag-expand, the Big Crunch nag nag-condense ag nag collapse afterwards. Now this is it. This is the illustration of the Big Crunch theory. The fourth theory is the pulsating universe theory. According to this theory, it's actually the combination of the Big Bang and the Big Crunch theory. So if we could have remembered, the Big Bang nag-expand, the Big Crunch nag-compress. So it's a combination of both. It's like there is an instance of Big Bang, tapos may instance man it Big Crunch. So to better illustrate, it's like this one. As you can see, may Big Bang, there's expansion, and then there's also contraction that results to Big Crunch. So it's kind of a process, a continuous cyclic process. Finally, one of the most common among religious organizations is the divine command theory, the theory of creationism stated in the Bible in the Genesis. According to this one, there is one almighty individual who created everything from the words from his mouth. So it's like the words became a reality. So, for example, in that Genesis Bible, he stated that, let there be light, and then light came in. So, this is the divine command theory. Let's watch this video about the beginning of everything.
The beginning of everything, the Big Bang. The idea that the universe was suddenly born and is not infinite. Up to the middle of the 20th century, most scientists thought of the universe as infinite and ageless. Until Einstein's theory of relativity gave us a better understanding of gravity, and Edwin Hubble discovered that galaxies are moving apart from one another in a way that fits previous predictions. In 1964, by accident, cosmic background radiation was discovered, a relic of the early universe, which together with other observational evidence made the Big Bang the accepted theory in science. Since then, improved technology like the Hubble telescope has given us a pretty good picture of the Big Bang and the structure of the cosmos. Recent observations even seem to suggest that the expansion of the universe is accelerating. But how did this Big Bang work? How can something come from nothing? Let's explore what we know. We can ignore the beginning part for now. First of all, the Big Bang was not an explosion. It was all space, stretching everywhere, all at once. The universe started very, very, very small and quickly expanded to the size of a football. The universe didn't expand into anything, space was just expanding into itself. The universe cannot expand into anything because the universe has no borders. There is by definition no outside the universe. The universe is all there is. In this hot, dense environment, energy manifested itself in particles that existed only for the tiniest glimpses of time. From gluons, pairs of quarks were created, which destroyed one another, perhaps after giving off more gluons. These found other short-lived quarks to interact with, forming new quark pairs and gluons again. Matter and energy were not just theoretically equivalent, it was so hot they were practically the same stuff. Somewhere around this time, matter won over antimatter. Today, we're left with almost all matter and nearly no antimatter at all. Somehow, 1,000,000,001 matter particles were formed for every 1,000,000,000 particles of antimatter. Instead of one massive ultimate force in the universe, there were now several refined versions of it acting under different rules. By now, the universe has stretched to 1 billion kilometers in diameter, which leads to a decrease in temperature. The cycle of quarks being born and converted back to energy suddenly stops. From now on, we work with what we have. Quarks begin forming new particles, hadrons, like protons and neutrons. There are many combinations of quarks that can form all sorts of hadrons, but only very few are reasonably stable for any length of time. Please take a moment to appreciate that by now, only 1 second has passed since the beginning of everything. The universe, which has grown to 100 billion kilometers, is now cold enough to allow most of the neutrons to decay into protons and form the first atom, hydrogen. Imagine the universe at this point as an extremely hot soup, 10 billion degrees Celsius, filled with countless particles and energy. Over the next few minutes, things cooled and settled down very fast. Atoms formed out of hadrons and electrons, making for a stable and electrically neutral environment. Some call this period the Dark Age because there were no stars and the hydrogen gas didn't allow visible light to move around. But what's the meaning of visible light anyway, when there's nothing alive yet that could have eyes? When the hydrogen gas clumped together after millions of years and gravity put it under great pressure, stars and galaxies began to form. Their radiation dissolved the stable hydrogen gas into a plasma that still permeates the universe today and allows visible light to pass. Finally, there was light. Okay, but what about the part we didn't talk about? What happened right at the beginning? This part can be defined as the Big Bang. We don't know at all what happened here. At this point, our tools break down. Natural laws stop making sense. Time itself becomes wibbly-wobbly. To understand what happened here, we need a theory that unifies Einstein's relativity and quantum mechanics, something countless scientists are working on right now. But this leaves us with lots of unanswered questions. Were there universes before our own? Is this the first and only universe? What started the Big Bang, or did it just occur naturally based on laws we don't understand yet? We don't know, and maybe we never will. But what we do know is that the universe as we know it started here and gave birth to particles, galaxies, stars, the Earth, and you. Since we ourselves are made of dead stars, we are not separate from the universe. We are part of it. You could even say that we are the universe's way of experiencing itself. So let's keep on experiencing it until there are no more questions to ask.
So, how was the Earth formed? What are the circumstances associated with it? Now, most researchers conclude that the Earth and the other planets form at essentially the same time, and it is discussed by the nebular hypothesis. It states that the solar system evolved from an enormous rotating cloud called the solar nebulae.